Welcome to surveying class. So in this class we'll be discussing about the fundamentals of mapping. So in the last class we have started our actual survey class. There we have discussed the different definitions of surveying, as well as what is the objective of surveying and importance of surveying for the civil engineering perspective and all. So all these things we have discussed in the last class in detail. So today in the lecture 2 we'll be discussing about the fundamentals of mapping. So in the last class, I hope you guys have understand that our main primary objective for this surveying is to prepare the maps or the plan for the entire area. So that is our more fundamental objective of surveying. So we have to prepare the maps or plan, right, for building, for construction of buildings. So we have to prepare the building plan in the sense, right, where we have the structures, maybe where we have the pools, where we have the garden, all these things we have to identify. And then again, in that construction of the structure also we may have structural plan as well. So, and for the country level, to prepare the country's map, we have to make use the surveying techniques as well. So our main objective in this course is to draw the map or the plan for the entire land, or whatever may be the given land. So mapping fundamentals. So let's discuss in details. So we understand that the surveying is basically the collection of data from the field surveying, right? And then we prepare the map. So this is the Indian map, Indian topographic map, right? So map also we discussed in the last class in many types. So like this map is a topographical map. So what is topographic map? So basically here in this map we are showing the topography, means the elevations, where we have the forest, where we have the hills, where the river passes. So all these things are shown in this map. Whereas in some other map, maybe the political map of India, where you will find the state boundaries of India in different states. So since the actual surface of the earth surface is curved and the surface of the map is flat, a method of projection is basically used, right? Because this entire area here we are showing it in a plain two-dimensional paper. But in reality, if you understand that earth is not a flat, right? It is a curve in nature. So this is a spherical earth. So what we do the projections, because you studied in the engineering graphics in the first year course also. So we have to use the projection because we are projecting here a spherical earth into a two-dimensional or flat earth. So however, no map can represent a location without any distortion, right? For example, this originally, if you look into this entire Indian map, so it is very difficult. You cannot exactly replicate what is there in Indian map. So always there will be some distortion from the original perspective, because many more state boundaries will be there, and that is also in a spherical coordinate, whereas we are drawing it into the two-dimensional coordinate. So that's why if you see in the map, Google map, if you open and if you see some like for the Australian continent and the Brazil and all these big continents, so in the map it some continent may look small, but if you find it, if you see the area of each country, each continent, it will be much larger than others. But because we are using some projections to from spherical coordinate to the flat coordinate, so that some maps may have some distortion on it. So to minimize the effect of distortion, basically conformal projections are generally employed, so that we can reduce as much as possible the distortions. So to prepare the map, first a grid of meridians and the parallels of latitudes is being prepared to provide the framework of the map, right? So in any map, basically we have the latitude in this direction, we have the longitude in this direction. So entire map, basically we first make it the grid side latitudes with 70, 71, 72, 73, like that. Each latitude grid point will be there. Similarly, we have the longitude grid points also, right, from 20, 21, 22, 23, something like that. Grid points will be running, latitude and longitude grid points. So that will make the actual the framework of this entire map. So from this control, no, from this framework, basically we finalize few control points, and then once we plot the control point means, as we discussed, control points are basically the points where we have the coordinates and everything we know, that we discussed in the last class also, right? For example, like Hyderabad here. So Hyderabad latitude and longitude we know at the center point, maybe at the somewhere maybe at the Hussain Sagar if you want to locate. So in that case, the latitude and longitude of this Buddha statue which is there at the Hussain Sagar we know. I mean, we know that. So first we identify that. First we make the grid points like 70, 71, 72, these latitudes, and longitudes also 20, 21, 23. Like the longitude grid points will be there. So in the grid point, now first we identify all the control points. So for example, that as I mentioned, Buddha statue's latitude and longitude we know. So identify, okay, here may be the Buddha statue. So something like that we have to do it. So first we have to make the grid points of no, of the entire domain, and then you have to locate the control point, because control point means where we know exactly the location, latitude, longitude, and all. So after that, with reference to this coordinate control points, basically we draw other features of the map, and then we prepare ultimately the final map. So that is the mapping fundamentals. Our main objective here is to prepare the map. How we do it? So the first step is basically to draw the grid point. So grid point means, as I mentioned, so this will be something like that, right? This is latitude, longitude, grid points we are making. So entire plot area is basically divided into multiple grids, something like that. Okay, so this is x coordinate grid point. Similarly, we have the y coordinate grid points also. So like the entire plane area, you divide it into grid points, and each grid point, so this is a grid point one, this is another grid point, right? So in these grid points, now we basically identify the control points, and then we prepare the maps. So now the next topic here we'll be discussing is the factor needs consideration for map. So while preparing the map or the plan, that is our main objective, right, in the surveying course. So basically, what are the factors needs to be considered while preparing the map? So first one is scale. So what is scale? Like we have the ruler, right, in the paper. When we used to draw the geometric shapes in a paper, we use the ruler. So ruler, in that basically our maps will be in a paper, right? In a paper basically we are drawing the map. So this is a paper I am talking about, and this may be a real land. So this is much real land in on earth basically. So you can imagine this is a big earth location, and this entire whatever, some location we have the river, some location we have the hills, right, some location we have the home, right, some location the road passes, something like that. So all these features basically we have to draw it on a paper, right? So all features we have to draw it on a paper, but the scale will be less, because here the entire length I was talking about is on earth. If you consider on Hyderabad, if you want to draw the plan of Hyderabad or map of Hyderabad, the entire grid point here to here, it may be, you know maybe 100 kilometer by 100 kilometer entire grid point. So you can imagine 100 kilometer by 100 kilometer area now we are duplicating on a paper. So papers hardly, this length maybe on a paper is 10 centimeter, and this also may be 10 centimeter, right? So this entire 100 kilometer by 100 kilometer map basically we are projecting on a paper which is still 10 centimeter by 10 centimeter, right? So that is our main objective here, to prepare this entire Hyderabad map into a small scale, right? So our first factors need to be considered is the scale. Scale means we are drawing the big structure into a small area, small paper, right? So scale by definition is called, you know the length in the paper by the actual length, we call it scale by definition. So for example, here the actual length is 100 kilometer. For example, this location to this location, so this location to this location is basically 100 kilometer, right? But we are drawing it in a paper is basically 10 kilometers. So the scale for this drawing will be, on paper it is 10, whereas in reality it is 100, right? So the scale will be basically 1 by 10. So that is the scale we are using, 1 by 10 kilometer per, and basically we are using the scale here. So this scale is sometimes also called representation factor, RF, representation factor. Basically the length on a paper divided by the length of actual length, that we denote it into the representation factor, we call it scale. So the first step will be to choose the scale. What is the appropriate scale we are using? Similarly, if you use the Google Map, if you open Google Map in a browser or in a mobile app, you will find at the bottom somewhere the scale will be mentioned. Something like, this type of lines, you will find it out. Something at the bottom, say 1 is to 1000, or something like that will be written in the Google map if you open. So that is basically nothing but a scale. Means on a Google map with the distance in 1 unit, means in reality the distance is 10,000. It may be kilometer or it may be centimeter depending on the scale, right? So that's what this we call it representation factor. 1 is to 1 means the length in the paper or in a mobile display, and in reality that one length is 10,000 kilometer or 10,000 meter, whatever may be the scale. So like that, we have to choose the scale. Okay, so once we choose the scale, maybe 1 is to 10 here, 1 is to 10 is the scale. Now next step we have to consider is the conventional symbol. What is conventional symbol? Like on a paper, this entire area or entire Hyderabad region where we have the Hussain Sagar and all these big structures, the stadiums, apartments, all these things are there. So this entire thing you cannot show in a paper, right? Because paper we have very limited space, and then we have to draw it also. So we use some conventional symbols, right? For the roads, maybe some standard symbols we'll use. If we have a lake, so we don't draw exactly lake, but you will give some symbols, maybe a cross or maybe a line, whatever it may be. So we have some standard conventional symbols to draw the uh, map. Similarly, generalization of details. So what is the third factor? Generalization of details means here on art, basically we'll have so many objects, right? So many apartment buildings will be there, schools, shopping malls, roads, all these things will be there. So you can't even give symbol for all the products or all the objects on a map, right? So in that also we have to cut short, right? For example, a lake is there, so we definitely show the big lake. Maybe small lakes we can ignore it on a map, because if you draw even small lake, the map will be very much congested and nothing can be interpreted. So that's why the important things only will show it in a map, not the everything. Like many roads will be there, right? But if double lane roads will be showing here, single lane or narrow roads we won't show in a map, for example. So that's why this is we call it generalization of details. Like all details we are not putting it here. Similarly, plotting accuracy also we have to consider. Like here, because this is a scaled structure, right? Scaled map we are drawing. So for that, so here if you have small error in the map, this will be reflected very high in the original space, right? So that's why plotting accuracy is also important. That also we have to be taken care. And then the rectangular coordinates, and to draw that, always we find it out some rectangular coordinates, right? And then we plot our maps. So we have to choose the rectangular map coordinate, means from where to where Hyderabad location will be starting, because the entire map of India, from there we are cutting the Hyderabad location only, for example, for preparation of Hyderabad map. So in that, what will be these grid points, right? This rectangular grid points, that also is important. So basically to prepare the maps, these five parameters has to be considered in details. So as I mentioned, the scale. So what is the definition of scale? Scale is the length on a paper by the length on a actual on earth. So the selection of scale also will be different. For example, maps, as I mentioned, maps may be we prepare maps for different uses. So for example, you want to construct a structure, or if you want to construct a structure, for example, for that you purchased a plot, right? In that case the plan will be very small, right? The plan area may be 100 200 meter by 100 meter, right? You want to construct a building here, so you purchase this plot in any location in Hyderabad, for example. Then this length in real, it will be 100 meter, for example, by 100 meter. Whereas if you want to plot the entire Hyderabad region, in that case, the entire length may be 100 kilometer by 100 kilometer. Okay, so that's why the scale is different here. So if you want to construct a plan for building, then the scale will be 100 meter you are displaying on a paper, maybe 1 centimeter. So here maybe scale will be 1 is to 10, whereas in the for preparing the Hyderabad map the scale may be 1 is to 100 or 1000, whatever it may be, depending on our scale. So depending on what map we want to produce, the scale also will be changing, right? So the selection of scale is one of the most important consideration during the mapping. So that is also very much important. Which scale will you consider for your map? So this is depends on, basically decides on the purpose of the map, like which map you are preparing. Are you preparing a plot map, or you are preparing a city map, or you are preparing an entire country level map, or you are preparing the entire world map. So which one you are doing? So depending on that, we have to choose. If you are constructing a small plot, then our scale size may be 1 is to 10. But if you want to construct a map for the entire Hyderabad region or the entire municipality or region, then you may use 1 is to 10,000 or 1,000, something like that. So the purpose of the map, it depends, right? So scale, it will choose what is the purpose of map you are using. Then the nature of terrain to be mapped. For example, you want to map an entire hilly region or maybe a dense forest. So in that case also the scale will be changing. So then the size of the final sheet, right, where you are printing. So that printing, if you are printing it on a A4 page, then you will use one scale. But if you are using for the A3 like big pages, in that case you can increase the scale as well, or you can decrease the scale, right, depending on the paper or depending on the size of the final sheet. You can choose the scale, right? So for example, if you open the Google map in mobile, so in mobile the display size is very less, right? Then in the same same mobile in the same location, if you open it on a web browser Google map, then the display size of our desktop is much larger, right, compared to mobile. Then the scale also, if you find in the browser, in the desktop, basically the scale will be less, whereas in the mobile the scale will be very high, 1 is to 10,000 maybe, because mobile the area size of final sheet is very less. Similarly, availability of resource to get it prepared and printed. So all these things are basically depends to choose the proper scale. So these are the different suggested scales available. You can choose any one of these depending on the purpose of survey. So for example, you want to survey the land survey, then the recommended scale may be 1 centimeter equal to 5 meter or 50 meter. That means what? 1 centimeter equal to 5 meter means what? Means where in paper with the length is 1 centimeter, means on a real site the length may be 5 meter. So if you want to do a land surveying, the scale may be chosen such that 1 centimeter may be 5 to 50 meter, any two value you can choose. For example, you want to survey a small area, in that case you can choose 1 centimeter equal to 5 meter. Whereas if you want to survey a large like a school campus or a college campus, that will be quite larger, right? In that case you can choose 1 centimeter equal to 50 meter. So depending on the land surveying, also depending on the area of the land you want to survey, you can choose the scale. So this RF, we call it representing factor, as I discussed in the last slide also. So basically from here we calculate. So if we consider the scale 1 centimeter equal to 5 meter, that means what? 1 centimeter equal to 5 meter means 1 centimeter on a paper equal to 5 meter on an actual ground. So then we call it representation factor RF equal to 1 centimeter means 1 centimeter by 5 meter, right? 5, if you convert it into centimeter, it will be how much? Multiplied by 100 centimeter. So now what is the scale? 1 by 500, right? So 1 by 500 is the scale or the representation factor, RF we call it. Okay. So so this 1 centimeter equal to 5 meter to 50, right? 1 centimeter. So now if you take the larger scale, in that case it will be 1 centimeter equal to 50 meter. So in that case, what will be the representation factor? RF. Representation factor will be 1 by 50 into 100, right? We are converting into centimeter, this also centimeter. Then the scale will be 1 by 5000. So if you want to survey a small apartment buildings or a small plot, in that case the scale can be chosen something like that. 1 centimeter is equal to 5 meter, means on a ground 5 meter length, in a paper it is 1 centimeter, right? But if you want to survey a university campus, in that case university campus is very big, so in that case that scale you can choose 1 centimeter on a paper equal to 50 meter on the campus, on the ground itself. So in that case, the representation factor may be 1 by 5000, right? So that's what is mentioned here. So for if you want to do the land surveying, the scale can be chosen 1 centimeter is equal to 5 meter to 50 meter. Then means representation factor 1 by 500 you can choose for the small area, but if the area is increasing, then you can choose up to 1 by 5000. So this is the 1 by 5000, right? This one we did it. So 1 by 5,000 area. So for if you are doing a land surveying, the scale can be chosen in between in this range. Similarly, if you want to do a topography survey, what is topography survey? Topography survey is basically, if you want to locate the hills or a river, all these things you want to locate of the entire, from the entire map. Like we have the topographic map of India, right? That is the Indian scale. It's a very large scale we are doing it. That's why you see that the RF factor also will be very high. Means 1 centimeter on a paper basically is denotes 0.25 kilometer from the real side. So you can imagine the scale is very high here. So 1 is to 25,000 is the scale here, RF, that is representation factor. Similarly, if you want to do the building site uh, survey, then maybe scale may be chosen 1 centimeter is equal to 10 meter, right? Or RF equal to 1 by 1000. If you want to do a road survey, means you want to construct a highways or a railways. In that case, we do the road survey, right? How much is the total length? So in a paper, basically we show where the road will be passing. So in that case, the map or the representation vector scale can be taken as 1 centimeter is equal to 100 meter. So 100 meter on site, we are representing only 1 centimeter line on a paper. So representation factor easily we can compute it. What will be the representation factor for this one? So that easily you can compute it. So this will be representation factor will be 1 centimeter on field and 100 meter on ground, right? 100 meter you have to convert into centimeter in multiplied by 100. So it will be 1 by 10,000, right? 1 by 10,000. So that is the representation vector. See, 1 by 10,000 is written here. 1 by 10,000. So similarly, if you want to construct a map for the Hyderabad or Delhi region, that is we call it town planning, right? For GHMC and all, you will find they have the plan. So in that case, the scale may be 1 is to 100 meter, you can 1 centimeter equal to 100 meter you can use the same scale you can use. So depending on the purpose what we are doing, so scale also can be changed. So we have to take the appropriate scale and then only we have to design it. Now, as I mentioned, that the 4 or 5 factors depending on for the preparing of map. So the first two factors we discussed, that is scale, right? And then the first factor we discussed, that is scale. The next factor is actually conventional symbol. As I mentioned, our map we are drawing on a small area, right? We have the very limited space on a paper for the drawing of different objects on Earth. For example, you want to construct a village or a church or a temple, right? So you cannot draw exactly a temple, right? Or if you write a temple, that also will take so much space. So basically this is the standard symbols we use. For example, you want to show in a map that this is a church. So in that case, if you write church, again it will take so much space. So simply you draw this type of small symbol, that is standard symbol. As per our survey of India, that is our regulatory body for the surveying in India, the government authority survey of India. So they have given this type of symbols which we can use. For example, if you want to show the temple, then this small temple you can show it. If you want to show a mosque, then this type of mosque symbol you can draw it. Okay, like that. Like you want to draw the some boundary pillars, then this type of symbols we can use, right? Some aerodynamic, like if you have the aerodynamic things, then this type of symbols you can draw it. Well means rounded. See, this rectangular means we are showing the boundary pillar. Similarly, if you have rounded dot, then we are telling it this is a well, means bore well, maybe water is being collected. Then we have the telephone line. If it is passes, then this is the symbol. Electric power line, then this is the symbol we are using for that. So each symbol will vary. Then by looking into symbol we can understand what are the features we want to show it. Similarly, railways, and then the railway tracks, metal roads, national highways, like that we show national highways. This is unmetal roads, means rural highways we show something like that. Level crossing means we are crossing the train line with, see, this is a train line and we are crossing with a highway line also crosses, so that we are showing it the level crossing. Then this is the footpath symbol. Like that, many symbols are there. So here I have just shown few representative symbols, but in their website or in their documentation you will find they're using so many symbols are there. So whenever we prepare the map, basically we use this much symbols to show the different features on a map. So now the next parameter is basically the map generalization. So what is map generalization? As I already mentioned, that on a field, so if you see this is the entire Indian map, So in this entire Indian map, basically we are showing the state boundaries, right? State boundaries. So inside the Hyderabad or inside the Telangana region also, right? This is our Hyderabad Telangana region, right? So this Telangana region also, you have the so many places, so many things will be there, right? We have Hussain Sagar at the center, or we have the different Hyderabad municipality. We have Warangal there, like all the places will be there, right? But we have a very limited space on a paper, so this is a very limited 10 centimeter by 10 centimeter space. So in that we can't show all the locations, we can't show Warangal, we can't show other districts of Telangana, even in for for the Delhi also we can't show all the districts in Delhi. Even inside the district also we have so many other places to show, but it is not at all possible in a simple map to show all the details. So that's why we are generalizing the important features which is very much essential. For example, in a state, which one is important? So in a state, obviously our first priority should be the capital, right? State capital. So similarly, that's why if you see this plot, if you see the state capitals has been shown here. In Hyderabad Telangana region, only Hyderabad has been shown. Similarly for Tamil Nadu, the only Chennai has been shown. That means the most important thing is capital, so that's what we are showing it here. But if you increase the, if you zoom it, so if you see, imagine if you zoom it means what? Basically you are decreasing the scale. So in that case, you can show, if you zoom it into the Telangana region, then you can see other features like other district wise division, you can see it, right? That's all. So depending on the scale basically, and we have to generalize the map, means which features has to be shown, that we have to finalize. Because since the map represents the art surface in a small scale, it cannot depict all the objects, right, on a map. So this process involves in selecting the essential details from the multitude of topical objective are represented, right? Like for this entire map, we choose the important things that we call it generalization. So salient points required for the generalization are: number one is the choice of object or feature of the correct object features in connection with its purpose and the scale of the map, right? So as I mentioned, for this, if you want to show the state, then the main important first object you want to show is the capital. That's why we are showing capital. Now if you zoom it into the only into the state, then you can show district wise divisions. So depending on the scale, basically we choose which the which object is important for us. Second salient feature is basically salient point is basically elimination of terrain details that cannot be maintained because of legibility or clarity of the map. So some information we won't show, depending on if it is not clear on the map, we won't show it on a map. So this will make our map simple. Simplification of the form of terrain details that cannot be omitted, but which detailed representation would be interfered in the image of the large. So that is the nutshell, means the important objects only we will show depending on the scale. So that we call it map generalization. The next important parameter is the plotting accuracy. So the precision of a map or a plan actually depends on the fineness and the accuracy with which the details are plotted, right? So that is, we call it accuracy. So moreover, the plotting accuracy on paper varies between 1 mm to 0.4 mm, right? Because in a paper we draw the map. So in that also, while drawing the map, we may do some mistakes. So mistakes means what? The small, maybe you want to show, for example, I'll draw it here. You want to construct the region. I'll take a color. Okay. So entire region, maybe entire Hyderabad region, you want to plot. So you have the you have identified at the center. You have the Hussain Sagar. Maybe you have here you have the Himayat Sagar, or maybe here you have the Osman Sagar, right? So all these lakes basically you are identifying on a map. So in that case, what will happen? Maybe accidentally you just little more extra size you have given for the Hussain Sagar. Maybe this is small error you made it. So on a paper, how much maximum error? Normally, how much maximum error we can do it? We can, the error on a paper may be in this range, like 1 mm error. Maybe we can do it on a paper, 1 mm to 0.4 mm. That means if you convert this error into the actual real structure, then this will be multiplied by the representation factor, and on field it may be 100 mm. So if you are doing mistake 1 mm, means 1 mm on a paper, then the in field the mistake will be 1000 mm, right? Depending on the scale. So that is very much important. That's what we call it plotting accuracy. So we have to be very accurate while drawing the objects on a paper, but still we'll have some errors because that is human error. Definitely we can't ignore. So even in the small error, if you do it, so that will have a large impact on the real structure or on the real earth uh, areas. So that is our fourth parameter. Now the fifth last factors which affects the map, or you have to choose it, is the rectangular coordinate. As I mentioned, so this is, you can see, the political map of India, and this map has been downloaded from the Survey of India website. So it's Survey of India website, if you visit, you will find the different maps of India. Like this is a political map. Here all the state boundaries and all districts will be shown here, whereas in other topographic map also you will find it in the Survey of India website. There you will find all the hills, regions, terrains, all these things you will find it out. So the rectangular coordinates means, here, see, this is the coordinates. These small lines you can see, this is the latitude, longitude, right? This is the grid points I was talking about. So basically when you construct any map for entire region, first thing we do is this rectangular coordinates, we find it out. Let's see, rectangle, see, this is a line, grid point, you can see this is a latitude, longitude lines. So these small lines, first we draw it. So once we draw these small lines, after that we fix the control points and at the different locations. So how do we fix the control points? Basically, we know what is the latitude and longitude of all the capital cities in India. Like in Hyderabad, we have this one. For West Bengal, Kolkata, we have Agartala, we have here. Northeast Assam, Guwahati may be here. So all the capital cities, latitude, longitude, we know. So first we identify the control points at the different locations, and then ultimately we prepare this type of maps. So the large scale maps of a plane surveying are generally prepared by means of survey system of rectangular coordinates with two reference axes representing east, west, and north, south direction respectively, in the horizontal and vertical direction. So what we do, we find it out some control points, and we finalize, and then we draw the grid points. So this the initial control point, we consider it at the center. For example, you want to construct the Indian map, right? So Indian map means the grid point we have to make it, a rectangular grid point we have to make it. So that then first we locate the center point, or near to the center point of the Indian region. So that we have to locate it first. So for Indian map, so as per our, that Survey of India defines the national rectangular coordinate system with the origin at the Kalainpur, that is in Madhya Pradesh. So Kalainpur, Madhya Pradesh, this is the center point. So from here basically we start our coordinate point. So if I draw it here, maybe somewhere here you have the coordinate point. So this is our grid point, starting grid point will be starting. Okay. So this is almost at the center of this entire Indian domain, Madhya Pradesh. So this location you can understand, maybe this type of questions may ask in the competitive exams as well. Kalainpur in Madhya Pradesh, basically maybe in somewhere here, in this location, that is our grid point, rectangular grid point will start from at this point. So that's why, so if you want to plot the Hyderabad map, in that case the center point of Hyderabad, we have to map it into the center point of this paper, and then we draw the rectangular coordinates, and then ultimately we prepare this type of plots. So that is the five parameters basically you have to be considered while preparing this type of maps. First one is what we call it, scale, right? What is the scale level we are doing it? Then obviously rectangular coordinates you have to make it. Then we are using symbols to show this is the for the to show the lines. If you see roads, see what type of lines has been used. So national highways may be shown here. So maybe state highways also may be shown. So one will be dark line, that may be highways, whereas we have one some artery lines also will be there, right? That may be the state highways. So depending on the symbols we may choose, right? So that's how we make the building and the maps. So this is the problem we'll be solving today. Now we understand how to prepare the map. So in this surveying course, our main objective is basically to prepare the map of a small land or a large scale, depending on our purpose. We prepare maps. Okay, so the example we'll be solving here is the representation function. So what is the question here? Question is, in a plan, a 10 centimeter scale drawn shrinks to 9.7 centimeter. If the scale of a given plan is written as 1 is to 250. Determine the actual length of line which at present shown 10 centimeter. What is this question? First you understand. In a plane means already you have a plane. So let's draw a plane. For example, you have already a plane. Plane means on a paper. So this is I am talking about paper. In a paper, already you have some plan of maybe in some region you have already. So already you have. So this is a scale. 10 centimeter scale is basically used, right, while preparing. So maybe at the 1920 year, so in this year basically you prepare this map. Okay, this is a map, for example, for this Hyderabad region. Okay, Hyderabad region, you prepared a map in a 1920, right, in a paper. So now the scale is what? It's 10 centimeter scale, right? 10 centimeter scale is used. Okay, so scale is basically 10 centimeter. So a 10 centimeter scale drawn shrinks to 9.7 centimeter, means this map is prepared in 1920, right? Now in 2020, right, 2020, so in 2020 this map, this is made up of paper, right? So paper, maybe because of some reason paper got damaged, and this entire map, the whatever length was there in 10 centimeter at the 1920, 10, this length maybe 10 centimeter it was in 1920, but now in 2020, after 100 years, this length has been reduced to 9.7 centimeter. That's what is mentioned here, because this is a very old map, right? We prepared in 1920. Like after 100 years this paper got damaged, and because of that this length, 10 centimeter length originally it was, now it is reduced to 9.7 centimeter. So that is the meaning here it is mentioned. Now if the scale of the given plane is written, so sorry, the scale was actually 1 is to 250, right? When it is drawn on a 1920, the scale was 1 is to 250. Determine the actual length of a line which is at present shown as a 10 centimeter. So now what will be the line? Now this map you have after 100 years, maybe 2020 now you have, and you have a length which is basically, maybe you want to find out this length. So this length currently it is 10 centimeter. Okay, currently this length is 10 centimeter. Now the question is, what will be the actual length now? So let me again tell you the question here. I am repeating the question here, that you have a map which is made at the 1920, and that time the scale is used 1 is to 250, means 1 unit on a paper is 250 unit on a field. That is the scale we have used in 1920. Now after 100 years, for example, this entire this paper got damaged little bit, because of damage it got shrunk little bit. Now the length which was there at the 1920, this length was 10 centimeter. Now this length is reduced to 9.7 centimeter. Earlier this length was 10 centimeter, now it is reduced to 9.7 centimeter. So that we know. Now in a map, now if you have a 10 centimeter length, if you find it out, this 10 centimeter, what will be the actual length of this 10 centimeter now presently is in 2020? That is the question. So how to solve this problem? So if this paper could not have shinked or could not have damaged, then 10 centimeter length on a paper will be 10 into, if you just multiply it with the representation factor. Representation factor means what? 1 is to 250 scale we are using, right? That means 1 unit on paper will be 250 unit on ground, right? Now if you have 10 unit or 10 unit on a paper, then it will be simply 250 into 10, right? 250 into 10 centimeter. This comes out to be 2500 centimeter. So if paper not shunks, then this 10 centimeter on a paper should be 2500 centimeter on a ground. That means 2.25 meter, right? 25 meter. So if paper is not damaged, then 10 centimeter length will be 225 meter. But what the question said? Question said the paper got shrunk by 10 centimeter, paper got shrunk by 9.7 meter, right? 7 centimeter. Then first you have to find out what is the representation factor, RF. So RF is given to us at the 1920s, this one, that is 1 is to 250. But now, because of damage in the paper, the RS representation factor got changed. Now, how much got changed? What is the current RF? That we have to find it out. So, how to find it out? So, with this value. So, when the length, when the paper means at the 1920, the 10-meter length, when the this distance was 10 meter, right? 1920, this distance was 10 meter, and that time, what was the representation factor? It is given, right? 1 is to 1 by 250. When the paper length was 10 meter, means at the 1920, the representation factor was 1 by 20, 1 by this one, right? This is given to us. So now, so when this is 1, right, simple arithmetic we are doing, then what will be the representation factor? 1 by 250 into 1 by 10, right? That's what we do. Now what is the present day? In present day, this 10-meter length now shrunk into 9.7, right? Then for 9.7, what will be the representation factor? This value multiplied by 9.7. 9.7. So this is now new representation factor. So earlier representation factor is 1 is to 250. So now this is our new representation factor, this one. So 1 by 250 into 9.7 by 10. So this is our new representation, present day representation factor, RF value, scale basically. So now we know the representation factor. Now easily you can find out now what is the distance. So representation factor. So if you convert it means, so now, so this is our representation factor. So if you just compute it, how much you will get it? So this will be equal to 9.7 by 2500, right? So 9.7 by 2500. So this is our current day representation scale. That means 9.7 centimeter on paper, on field actually it is 2500 centimeter, is not it? So now 1 centimeter on paper will be 2500 by 9.7 centimeter on field. Now we are finding out 10 centimeter on a paper will be this multiplied by 10. 2500 multiplied by 10 divided by 9.7. So now if you do it calculation, you will get it this one, 2.25.77 meter. So that is the question. So now actual distance will be 25.77 meter. Okay, now presently if you find out 10 meter length on a map, that will be 10 centimeter distance on a map. This will be 25.77 meter on an actual earth. So that's how we use the representation factor or to the scale, to represent the entire area into a small paper. So please understand this example and try to solve many more examples which is given in the textbook. So this concludes in this lecture. So in this lecture, what we have discussed the mapping fundamentals, the fundamentals of map. So while preparing the map, what are the things you need? So first thing you need is scale, right? Depending on the purpose of map, first we make the scales. Once we know the scale, then we use the symbols to present the different objects on a map, and then we use the generalization of details so that the important details only can be shown in a paper, and then we use the rectangular grid point to map the entire area on a small paper, and then we use the plotting accuracy also, that if you make a small mistake on a paper, it will have a large impact on a ground, right? That also we take care while drawing the maps. And then at last we have solved one problem, that is representation factor, how we compute it, and if you have a representation factor, how to find it out the actual length. All these examples, small examples, we have explained in the class. Thank you.